name is Steve Scott, and I'm very excited to introduce you to a project I've been working on called DCAT. DCAT is a USB-based portable e-discovery tool. Essentially, a bootable USB appliance capable of non-intrusive analysis, cataloging, and searching of any computer system which can run Linux and file system capable of being read by Linux. DCAT is modular and designed for extensibility and adaptability. What this means is one person would use DCAT possibly to create a catalog of their media library, while another person might use DCAT to create a catalog of virus signatures on a particular computer system. A legal team would use DCAT to perform e-discovery against a computer system, searching for documents which had relevance to ongoing litigation, as well as exporting those documents in a format suitable for them. DCAT achieves this through the use of adapters, which are based on file type or magic number. Adapters can be activated and deactivated to focus on the data that's important to you. The adapters provide one of two functions, either contextual interpretation and normalization of the target data, or extraction and format conversion for data exportation and gathering purposes. DCAT provides an open interface to allow for custom adapters to be built. For example, someone may want a custom adapter to scan for logic vulnerabilities in programs or DLLs, while another person may want a custom adapter to search for particular objects in images. Your imagination is the only limit to what you can create adapters to search for. DCAT is built completely on open source software and uses Apache Lucene as the underlying catalog database. It's a very quick database, well known throughout the world, and used extensively across the web to index websites. But without further ado, let's move on to the demonstration. To initialize DCAT, simply insert the USB drive into the target system, power on or reboot it, and access the boot drive selection option from the BIOS splash screen when it appears. I am using a virtual machine for my demonstration. Therefore, USB does not appear within my boot screen list. I have DCAT installed on the hard disk, and I will be using a removable device to scan. Everyone else, USB is the selection you want. So I will go ahead and begin booting from the hard disk. The operating system and catalog of DCAT reside on an encrypted segment of the flash drive to secure the catalog and prevent tampering, and an unencrypted area of the flash drive is provided for exporting items too. During the initialization, the disk discovery service is started, and if a network is available, any updates for DCAT that are available are downloaded and applied. Once the system initializes, we are presented with the drive selection screen. At this point, any removable media can be attached if desired. Simply click the PF5 key until it appears in the list, which will be roughly 10 seconds or so. I need to attach my USB drive to this virtual image, so I will do that now. And I will hit PF5. See it in the drives list. There we go. There's my 16 gig removable device I intend to scan. So I will select it. And hit the scan button. Once the scan has begun, drives are attached read-only for non-intrusive analysis, and the execution log is displayed. Apache Lucene provides the catalog engine services. Indexing may take some time depending on the amount of data selected and the focus and intensity of the adapters chosen. I have chosen a set of document-oriented adapters, so this shouldn't take too long. During the catalog phase, file types are indexed if an adapter is present. The adapters I'm using currently also include optical character recognition against any images to derive any text that may be included in those, and if they are scans and such thing.
It is useful for scanned documents, faxes, etc. PDFs, Words, Excel documents are being indexed. Outlook mailboxes, any emails within those, any attachments are also indexed. And each adapter defines the extent of the indexed content. For example, email content is cataloged along with fields for recipient and sender email addresses, sent date time, email subject, etc. While a PDF is cataloged with just the textual content, post OCR, in case there are images within the PDF as well, and any metadata associated with it. In addition to adapter-specific context data, DCAT always includes, as I said before, the system ID, either from the BIOS or user overridden, the drive UUID, and all the file information for the file that was selected and cataloged, which includes the date time created, modified date time, size, path, etc. This particular scan takes around 8 to 9 minutes using a 16 gig flash drive, and that is somewhat in line with Lucine's boasted rate of 150 gig hourly. Just remember that doesn't include decompression or extraction of things like zip file, Outlook mailbox contents, hardware capability, etc. But while we're waiting, let's take a look at the basic architecture of DCAT. DCAT is built on a customized Debian LAMP stack and uses Apache Lucene at its core. In addition to vanilla OS services supporting LAMP stack and web-based GUI services, DCAT initializes several of its own services. The index server receives catalog requests and dispatches them to Lucene. The work queue service coordinates scan requests and dispatches index processes. An export server receives export requests and drives the export adapters. And the media survey service simply detects additional storage devices if they've been attached. Finally, there are two WebSocket servers. One provides output from the execution scan. Well, that's this one here. And the other one coordinates export requests and results between the GUI and the export server. Taking a closer look into the execution of the scan itself, once a drive or drive has been selected for cataloging, the work queue manager is notified, and it facilitates execution of the work manager against those selections. The work manager dispatches worker processes which execute the appropriate adapter for the file in question. The resulting information is delivered to the index server for cataloging in the Lucene data store. This architecture is designed to enable a server-based implementation with minimal effort. So we'll check back on the scan, and we're done. We're still running here, so let's give it a little while and we'll check back in a few moments. Scanning ends with the notification that it is indeed complete, and total elapsed time is shown in the log view. Click OK to move to the search interface. Before I go too much in detail with the search interface, I'd like to talk about another area where DCAT is constantly evolving and improving. We are aggressively working on Lucene API upgrades to provide a more appropriate post-scan interface, the statistic view, which is represented by this icon. Currently, this is a non-functional mock-up to provide a sample of the type of analysis which will be available once these API upgrades have been implemented. Flot is an open-source JavaScript framework used for the graphing, and it provides a full suite of data representation tools. This is just a small subset of what it can do. But back to the search interface. The catalog can be searched using free-form text, file extension, size, etc. This is one of the areas that will be expanded once the API upgrades are made as well. and allow for more dynamic search capability for more contextual information, such as song title, lyrics, that sort of thing. Basically, any field that's been cataloged will be searchable or selectable for search. So we'll just search for something that I know is out there. Oh, look, there's Rex. Rex is a programming language, something fairly unique, and I know it will be found. So we hit the search button. 2 files are found. If you mouse over them, you can see a quick little pop-up is displayed for that item. If you'd like to see it in more detail, just click on it. It will open up a larger window so that you can read the actual contents that have been indexed. Just a bunch of bookmarks that I had, which apparently have Rex somewhere in there. We'll take a look. Vendor and TS, we're going to find Rex in here. That's just a quick look at the results of a search. If these were documents that I wanted to export, I would simply select the export checkbox, and I get a notification that it has been exported. File exportation runs asynchronously to allow continued review of any results and additional export requests. Again, exportation is only possible while running on the target system with the physical drives which created the catalog available. Some exports may take a while if it's from an Outlook mailbox or from a zip file. That's why exportation has to run asynchronously, and this all communicates back with the WebSocket server as discussed earlier in the architecture. Once your results have been reviewed and any exports have been completed, you can go check the export area to review it to make sure you've got everything you wanted. That's represented by this icon at the bottom. And there you see the document that I have exported. Once your exports are done, your activities are complete, the system can be shut down and the USB removed for later review of exported document files on another system. The catalog will remain intact until another scan is performed. If you want to go back and re-examine or research from another system at your own leisure, you can do that. We'll go ahead and shut this machine down.
And that concludes our demonstration. At this point, you can take your DCAT USB, boot it on another system, continue searching the drive, remembering that the exportation will not be possible since you don't have the target system, or take it to a system and insert it, and any export documents you would be able to pull up for further review. Thank you for taking the time to review this demonstration. I hope you find the product useful. If you do, please feel free to give me a contact, StephenWScott@hotmail.com. Thanks again.